All right, let's dive right in. Today, we're going to peel back the curtain on system architecture. We're talking about the brilliant ideas that make the massive apps we use every single day, well, work.
I mean, have you ever really stopped to think about it? You hit play on a new show, you click Add to Cart, and it just happens, instantly. And you're doing this at the exact same time as millions of other people. How on earth does it not all just fall apart?
Well, the truth is, it's not magic at all. It's just a collection of really, really smart, interconnected ideas. And we're going to walk through some of the biggest pieces of this puzzle, one by one.
So, where do we even begin? Well, first things first, you've got to handle the crowds. Imagine you're running a massive digital city. Your number one job is to keep all that traffic flowing, nice and smooth. Our first secret weapon is something called a load balancer. And it does exactly what it sounds like. It balances the load. It takes every single request coming into your app and spreads it out evenly across a whole team of servers. This is the core idea that lets a website go from serving a dozen users to millions without even breaking a sweat. The easiest way to picture it, a load balancer is basically the friendly traffic cop for your application. It's standing at this super busy digital intersection, just calmly directing every car or user request down different roads to make sure you never, ever get a traffic jam.
Okay, so we're not crashing. But what if your app feels slow? If your user is in Tokyo, but your main servers are in New York, that's a long trip for data. And that's where a content delivery network, or CDN, becomes a total game changer. Think of it like a huge online store. Instead of shipping every single package from one giant factory in the middle of the country, they have smaller, local warehouses everywhere. So when you order something, it comes from the one right around the corner. A CDN does the exact same thing with your data, cutting down delivery time and making everything feel lightning fast, no matter where you are in the world.
So we've got the traffic under control, but what about the data itself? We are talking about mind-boggling amounts of information. Every user profile, every product, every single show you've ever watched. How do you possibly store all of that and find anything quickly?
You can't just cram it all into one gigantic database. It would grind to a halt. And the solution is a really clever technique called sharding. Basically, you take that massive database and you smash it into smaller, way faster, more manageable pieces called shards.
Here's a great way to think about it. Instead of one single library trying to hold every book ever written, imagine you organized it into separate buildings for each genre. One for sci-fi, one for history, and so on. Now, when you want a specific book, you know exactly which building to go to. That's sharding. It makes finding data incredibly efficient.
So how does it actually work? Well, it's pretty simple, really. First, you pick something called a shard key, say the user's country. Then you use that key to split the data. So all German users go in one database, all Brazilian users in another. That way, when a request comes in, the system knows exactly which smaller, faster database to check. It's so much smarter.
Okay, so we have our servers handling traffic, our databases managing the data, but an application is made of dozens, sometimes hundreds of little services. How do they all talk to each other without causing total chaos? One of the most powerful ways is using a message queue. You can think of it like a buffer or a middleman that sits between your services. So one service, the producer, can just drop off a message, something like, hey, send a welcome email to this new user, and then it can immediately get back to doing its own thing.
This is amazing because it lets all your services work independently. The email service, the consumer, can just pick up that message from the queue and deal with it whenever it has a free moment. It's like a digital post office box. You drop off the letter and you just trust that it'll get delivered. You don't have to stand there and wait. This makes the whole system so much more flexible and resilient.
Now there's another flavor of this called publish-subscribe, or just pub-sub for short. It's a little different. Here, a producer sends a message to a general topic, not to anyone in particular. Then, any other service that has subscribed to that topic gets a copy of the message.
So what's the real difference? It's simple. A message queue is like a direct letter. It's one-to-one. But pub-sub, that's a broadcast. It's one-to-many. It's like a radio station sending out a signal that anyone with a radio can tune into and listen. One is a private note, the other is a public announcement.
So our system seems pretty perfect now, right? It's handling traffic, managing data, all the parts are communicating. It's great. But let's be real. In the real world, things break. Servers go down. Services fail. What happens then? And that brings us to our final and maybe most important section, building in resilience.
A truly great architecture isn't just about how fast it runs when everything is perfect. It's about how it behaves when things start to go wrong. These are the emergency services for our digital city.
Our first line of defense here is rate limiting. This is basically a shield that stops any one user or service from hammering your system with too many requests at once. It doesn't matter if it's a malicious attack or just a buggy script, rate limiting makes sure everyone plays fair.
You want to know the best way to picture this? It's the bouncer at a super popular nightclub. They're letting people in at a nice, steady pace to make sure the club doesn't get dangerously overcrowded. If you try to rush the door with all your friends, they're going to tell you to wait your turn. Simple, but incredibly effective at keeping things stable. Okay, but what if one of the other services your app relies on starts to fail? If you just keep hammering it with requests, you're not only wasting your own resources, you could actually start a chain reaction that brings your own system down. And that is where the circuit breaker pattern is an absolute lifesaver. A circuit breaker is literally like the fuse box in your house. It's constantly monitoring for faults. If it sees that a service is failing over and over, it trips the breaker. It just stops sending requests to that broken service for a little while to give it a chance to recover. This is so critical because it stops one small problem from turning into a massive system-wide outage.
So, there you have it. We've built up an architect's toolkit. We've got load balancers and CDNs to handle the crowds. We're using sharding to organize huge amounts of data. We have message queues and pub sub for clean communication. And we've built a safety net with rate limiters and circuit breakers.
But honestly, this is just scratching the surface. The world of system architecture is huge, and it's changing all the time. And that brings us to the final question from our source material. What's missing? Which crucial concept do you think belongs on this list? What would you add next?